Next question. Two waves having equation x1 equals a sine omega t plus kx plus phi 1 and x2 equals a sine omega t plus kx plus phi 2. If in the resultant wave, the frequency and amplitude remain equal to those of superposing waves. So what is given? The resultant wave is also having amplitude equal to these two superposing waves. Therefore, resultant amplitude A equals A and frequency is also equal to initial frequency of individual wave. Then what is the phase difference between them? So let me write the two expressions. X1 is A sine of omega t plus kx plus phi 1. Phi 1 is the phase constant of first, and x2 equals A sine of omega t plus kx plus phi 2. Actually, when you have two waves and their phases are known to be phi 1 and phi 2, we can convert this into one single form instead of writing two, considering the phase difference between them. Let's say phase difference between them is phi, that is equal to phi 2 minus phi 1. But how does the resultant wave look like? It is also having same amplitude. Therefore, what is amplitude of the resultant of these two waves? Amplitude A equals square root of a1 squared plus a2 squared plus 2 times a1 a2 cosine of phase difference between the two waves. Now let's substitute the values. Resultant amplitude A is equal to small a, and square root of amplitude of first wave is a squared plus amplitude of second wave squared plus 2 times first wave amplitude into second wave amplitude, and cosine of what is the phase difference? Say it is 5. Square it on both sides. So what do we get? A squared equals a squared plus a squared is 2 times a squared plus 2a squared cos phi. What I can do is divide throughout by a square. So I get 1 equals 2 plus 2 cos phi, that is by dividing throughout by a square. Or you can simplify this to get 2 cos phi equals minus 1, or cos phi equals minus 1 by 2. So what is the value of phi therefore? Let us go by eliminating method. Pi by 4 cos pi by 4 is 1 by root 2. Therefore, what do we get? This is not the answer. We shall get minus half. So option D is wrong. How about option C, pi by 6? Cos pi by 6 is root 3 by 2. That is also wrong. And cos pi by 3 is 60 degrees. That is 1 by 2, but we have the answer negative 1 by 2. So option A is reading 2 pi by 3. 2 pi by 3 is 120 degrees. So I can write cos pi equals, or cos minus 1 by 2 equals cos 180 minus 60. Therefore, that is cos 120. The value of phase difference is 120 degrees, or 2 pi by 3 radians. So option A is reading correct answer. Next, in a stationary wave, all the particles are, a stationary wave is considered, and the options are: in the region between two antinodes, vibrate in same phase; of the medium, vibrate in same phase; on either side of a node, vibrate in same phase; and in the region between two nodes, vibrate in same phase. Now let me draw standing wave. So this is a standing wave of length lambda. Now let's look at it. These two are endpoints, and there are three nodes and two antinodes. Now, in the region between two antinodes, they vibrate in same phase. Two antinodes is this region. Are they in phase? No. When this part is going upward another part is going down. So that means only the region between two consecutive nodes is in phase. It is rising upward, whereas the very adjacent region is moving downward. But if you compare with the region between two antinodes, this is antinode, this is antinode. They are not in phase, they are out of phase. Now, option B of the medium vibrate in same phase. No, they are out of phase. Option C, on either side of a node vibrate in same phase. Either side of a node. This is a node. On one side it is going up, on the other side it is going down. So this option is also wrong. In the region between two nodes, only between these two nodes or between these two nodes, all the particles are in phase. If they are going down, they are going down or in the opposite direction altogether. So option D is reading correct answer.